Hi, today we are going to study assembly line scheduling of dynamic programming problem. First, we will see what is the assembly line scheduling problem, followed by an example and a method to solve the problem and algorithm for the same. Let us start with assembly line scheduling problem. In assembly line scheduling problem, there is one manufacturing company who has two assembly lines. In each line of assembly, there are set of stations. Say, for example, in this assembly company is having two lines of assembly. That means here line 1 is having 3 stations and line 2 is also having 3 stations. A station S of ij is denoted as assembly line I and station number j. Say for example, this is S of 2, 2. That means it is on line 2, station number 2. Or say for example, this particular station S of 1, S of 1, 3. That means it is present in line number 1 and it is station number 3. The time taken by each station to process some good is given by Aij. That is, the time by S22, that is line 2 station 2, is taken as A of 2, 2. Each station is dedicated to some sort of work. Say for example, first station is performing body manufacturing, second station is performing interior manufacturing, and third station is actually doing processing or coloring of some good. So that is nothing but series of process. Each station is doing only one type of work in a manufacturing process. With the help of complete example, let us understand how assembly line scheduling works and what is our goal. So here this is car manufacturing company in which chassis must pass through each of the end stations before it exit company. Say for example, if car is entered at entry, it must get out from exit station, but before it get exited from this factory, the car must go from each and every station. So in this example, if there are 3 stations, then a car cannot skip any one station. It is compulsory to get processed at each and every station. Parallel station of two assembly line is actually performing same task. That means station number 1 1 and station number 2 1 is all doing same task. So car can go either to station 1 of line 1 or station 1 of line 2 because they are doing the same task. After it passes to some station S of ij, it continues to next station S of I, j minus 1. That means after from station 1, 1, a car can directly go to station 1, 2. That is the next station in a same line. But if that station is not free or if that next station is taking so much time, then a car from station 1, 1 can go to station 2, 2. That means second station of another line, line number 2. If a line is changed from one station to another, then we have some transfer cost to transfer a car from one station to one line to another line. The conclusion over here is simple. From one station to another station in a same line, if car is transferred, no cost is incurred, it can directly get transferred. But if from one station to another station of another line, a car is traversed, then we have some transfer cost which is incurred with it. So here, every transfer from one line to another line is denoted by T of ij. Plus, every line has its own entry and exit time. Entry and exit time of line 1 is E1 and X1, as well as entry and exit time of line 2 is E2 and X2. Here, our objective is to find optimal scheduling or an optimal path which gives fastest entry to exit way. That means the time incurred in processing at all stations, including entry and exit, must be optimal or minimum as possible. Say for example, consider this assembly line where there is one entry and only one exit. Entry 1 is 10 and exit 1 is 18, which is denoted by blue and pink circle respectively. For line 2, entry and exit values are 12 and 7 respectively. Now station of line 1 are taking time 4, 5 and 3, and station on line 2 are taking time 2, 10 and 1 respectively. Transfer cost from station 1 of line 1 to second station of line 2 is 7, and from station 2 of line 1 to station 3 of line 2 is 4. Similarly, to transfer from line 2 to line 1 of station 1 to 2 is 9, and cost of transferring from station 2 of line 2 to station 3 of line 1 is 2. So the weight on processing time at each station is given. We have to find an optimal path from entry to exit such a way that it includes minimum cost or minimum time. So let us calculate finish time at each station. So F1 is finish time in line 1, F2 is finish time in line 2. F1 of 1 is finish time of line 1 in station 1, which is given as entry 1 plus station 1's processing time, that is A of 1, 1. That means sum of the node 10 plus 4, that is equal to 14. Now F2 of 1 is given as line 2 station 1's finish cost. So finish at line 2 station 1 F21 is given as entry 2 plus processing time of station 1, that is 12 plus 2 is equal to 14. Now these calculated values needs to be stored inside a table of finish time. There are two types of finish time. Finish 1 is nothing but line 1 finish time, and finish 2 is line 2 finish time. Each line has 3 stations, that's why we are having 3 rows: station 1, station 2 and station 3. First cell is line 1 station 1 finish time, and second cell is line 2 station 1 finish time. We also have to keep track of lines for which we are working. So we are going to just copy this finish timetable as our line timetable, in which line 1 and line 2 are our columns and number of rows are S2 and S3. We are always going to skip S1 in every case. So entry for F1 of 1 is 14 and F2 of 1 is also 14. That means station 1 line 1 finish time is 14 and station 1 of line 2 finish time is also 14. So the respective entry is made in a table. Now let us calculate station 2's finish time. Now there are two stations, station number 2. First station is in line 1 and second station, station number 2 is present in line 2. So finish time in line 1 of station 2, F1 of 2 is given as minimum of some value, some value. Now let us understand these terms. Inside minimum function, our first term says finish of line 1 station 1 plus processing time of station 1 2. That is the finish time of station 1 line 1 and processing time of line 1 station 2, that is 14 plus 5. What is second term saying? It is finish time of line 2 station 1 plus transfer from line 2 to line 1 plus the processing time, that is finish time, that is the time of transfer plus the processing time. So that is calculated as 14 plus 5, that is our first value, and second value is 14 plus 9 plus 5, that is equal to minimum of 9, that is equal to minimum of 19 and 28 whose minimum value is 19. But this 19 is whether it is first component inside minimum function or second component. Of course, this is the first option that we have chosen. So inside S2 line 1, we are going to make an entry of 1, and then by that same table in the same cell, we are going to make an entry of 19 that we have just calculated. Now station 2 finish time at line 2, that is F2 of 2. Finish at line 2, station 2 is equal to minimum of some value, comma, some value. Now what is this? This is F1 of 1, that is line 1, station 1 finish time, plus transfer from line 1 to line 2, plus line 2, station 2's finish time. That is equal to this value 14 plus station 2's time plus transfer value. That is equal to 7. So value or components will be 14 plus 7 plus 10. Second component is finish time at line 2 station 1 plus processing time at line 2 station 2. That is equal to 14 plus 10. So here 14 plus 7 plus 10 and 14 plus 10. Sum is 31, 24, out of which 24 is minimum value. So that 24 will be taken out. This is the second option inside minimum function. So an entry in a table will be made for S2 is 2 and in finish timetable entry will be made as 24. Now we will calculate finish time of station 3. Finish time at station 3 line 1 is F1 of 3 will be, which is minimum of line 1 station 2 finish time plus processing time of line 1 station 3. That is the first component, which is equal to 19 plus 3. And the second component is finish time at line 2 station 2 plus transfer from second line to first line plus processing time of line 1 station 3. That is equal to 24 plus 2 plus 3. Minimum function will be 19 plus 3, comma 24 plus 2 plus 3. That is minimum of 21, comma 29, which is equal to 21. The 21 is the first component that we have written. That's why an entry in line table will be made as 1. Similarly, an entry in finish time will be made as 21. Now let us calculate for station number 3 in line 2. Station number 3 in line 2 is, first component is finish time line 1 station 2 plus transfer time plus processing time of station itself. And the second component is station number 2 in the same line 2 and processing time of station itself. That is equal to 19 plus 4 plus 1, comma 24 plus 1. Minimum out of 24 and 25 is 24. So this is the first component inside minimum function that we have selected as our answer. So an entry of 1 is made inside line table and entry 24 is made inside finish time table. So this is completion of table. Now we have to find out final finish time, that is F star. F star is given as finish time at line 1 station 3, that is the F1 of 3 plus exit time of line 1, comma finish time of line 2 station 3 plus exit time of line 2. So F1 of 3 plus X1 is equal to finish time at line 1 station 3, which is given inside the table, and exit time, which is mentioned inside graph or figure itself. So 21 plus 18 will be our first component, and second component is F2 of 3. That means station number 3 of line 2's finish time is given inside finish time table, that is 24 plus exit time at line 2, that is equal to 7. So 24 plus 7 will be our another option. So here minimum of 21 plus 18, comma 24 plus 7, that is equal to minimum of 39 comma 31. Minimum is 31, which is second option inside minimum function. So L star will be 2. In this case, it will be, so L star in this case will be 2. Now let us look at assembly line scheduling algorithm. It takes 4 arrays, an array A which is 2-dimensional showing line I station J processing time, an array T which is showing transfer from one line to another line value. An array E is showing entry and exit time of line 1 and line 2, and array X is showing exit time of line 1 and line 2. N is nothing but number of stations in a given table or given manufacturing unit. F1 of 1 is given as entry 1 plus A1 of 1, and F2 of 1 is given as entry 2 plus A of 1. From second station to nth station, that is from J A2 to N. If F1 of J minus 1 plus A1 of J is lesser than F2 of J minus 1 plus T of 2J plus A of 1J, then the first value, that is the minimum value, will be copied inside F1 of J and 1 will be stored inside L1 of J. But if this is not true, that means my second component of comparison sign towards the right is lesser. So in else case, F1 of J will be of the other side component, that is F2 of J minus 1 plus P2J plus A of 1J, and L1 of J will be in this case 2 values. Let us compute for finish time at line 2 J station. So that is given as if F2 finish time in line 2 of J minus 1th location plus processing time of line 2 J station, that is A2 of J, is lesser than finish time 1 of J minus 1 plus T of 1J plus A of 2J. Then we are going to set finish 2 time of J. F2 of J is F2 of J minus 1 plus A of 2J, and L2 of J is 2. But if that is not the case, in that case F2 of J is another component of a comparison sign, that is F1 of J minus 1 plus T1 of J plus A2J, and L2 of J in this case will be 1. After this finish time of line 1 of station J and line 2 of station J, we have to find out F star. F1 of n plus exit 1, if it is lesser than F2 of n plus exit 2, then F star is F1 of n plus exit 1, and L star will be 1 in this case. But else part, or if this is not true, that means F star will be F2 of n plus exit 2 and L star will be equal to 2. So this is the algorithm to generate our finish time matrix, line matrix, and F star and L star value. How to find an optimal path? So let us start with F star and L star. L star is 2 and last station in a figure is third station. So we will start our algorithm by line star station number n. So we will write down from exit we are walking towards the entry side. So initially line star is a line which is showing a line over which nth station is to get selected. The line star value is 2 and station n is the third station. So we are going to select a station number 3 in line number 2. The line 2 station 3 is selected. Consider line 2 station 3. Here we will look in column number 2 and row number 3. So column number 2, row number 3, value of the cell is 1. So cell number value is 1. So in next line we are going to write down line number 1 and station number next. So the previous station was station 3. So our next station will be station number 2. So this value 1 is the line number of our next station. That is line 1 station number 2. So that is also selected. Now consider last line, that is line 1, station number 2. We are going to look inside line or column number 1 and row number 2. Column 1, row number 2, value is 1. That means in next line we are going to print line 1 and station of our next station. So after station 3, 2, we will work for station number 1. That is line 1, station 1 will be U. So this is the complete transition from start to end. Now we will work from bottom to top. Line 1 station 1 will be selected. Line 1 station 2 will be selected. Line 2 station 3 is selected. So we will make use of that transition. From line 2 station 3 is selected and from where we have to make an exit. So the complete part is highlighted by cells entry 10, 4, 5, transition of 4, 1, 7 and finally exit. An algorithm to print the particular path takes L table as an input, which is a two-dimensional table, L star, which is our final line number, and N is nothing but number of stations. Initially we print line number L star and station number N is selected. Then we will put I as L star. So initial line is L star. Stations are working from backward, that is from second, nth station, third station we are going to back station up to station number 1. So here we will start our loop by n and go up to 2. Next line number is I, that is equal to in a line table jth row and ith column, that is L of ji. Then we will print line I station number j minus 1. For j equal to n, station number will be printed as n minus 1. For j equal to 2, station number will be printed as 1. So from n minus 1 to first station, we are going to make use of for loop. And inside for loop, we are going to look up inside line table, that is L, in which our station number becomes row and previous line number becomes column number. That's why it is L of ji is giving us next line number I. And finally printing line I station j minus 1 is selected. Thank you everyone for watching this video. This is Munira Topia signing off.